Welcome to Rajant's December webinar. Today's topic is That Was Easy. My name is Todd Rigby. I'm a Director of Sales for Rajant, and I have the pleasure of being your host today. This session is being recorded and will be posted to the partner portal in the next few days. As such, we have everyone on mute. I would encourage you to share a link off the partner portal with any of your coworkers who were unable to attend. There is going to be a couple of question and answer sections during the webinar. Feel free to type your questions into the chat feature as you think of them. If you're not familiar with Zoom, the chat feature can be found by clicking on the three horizontal lines in the web meeting taskbar. At the next Q&A break, I will call on you when it's your turn to ask your question. And now I'm struggling with the slides. Sorry about that. Our speakers today are Stephen Griggs, Vice President of Sales Engineering. He will review non-mining examples, as well as Philip Hendricks, our Sales Engineering Manager from APAC, and he will review mining examples. And with that, I'll turn the time over to Stephen.
Good morning, good afternoon, and good evening to all of you. The objective of this webinar we have a few objectives here. First of all, we want you to learn a bit more about how network drift can potentially affect your Kinetic Mesh network, and also to take a fresh perspective on optimizing your Kinetic Mesh. And when I say that, I'm not talking about buying more equipment or licenses or anything else. I'm talking about using the tools that you currently have and breadcrumbs you currently have. So what we're going to try to do is show you that what you currently have will likely accomplish all of the tasks that you need your network to accomplish without a big forklift upgrade or anything else. And I just kind of covered that, so let's move on. So first of all, if you've attended any of the Rajant maintenance webinars, we always talk about solving or troubleshooting networks, and we always liken it to putting together a puzzle. So in that, we're going to take a look at network drift, first of all, and understand A, what causes it, or some potential causes of it, and B, how to rectify it. So those are things that, you solve that problem. If you're cognizant of A, network drift that's happening in your network, and B, how to jump on it pretty quickly and solve it, you'll find that your network stays pretty healthy, and the addition of new applications and things like that become a whole lot less painful. And in doing so, we want you to have a look at BC Commander, which is Rajant's probably most powerful tool in your toolbox. BC Commander is capable of so much. It's really kind of the go-to when it comes to your network, your real-time network monitoring. So first, what is network drift? We've done a few videos, and we've done, this has been the subject of videos and even webinar. Network drift happens to 100% of the networks, 100% of the time. I've never known it to not happen, especially in mining. But certainly other platforms and other use cases is, you'll find that over time, your network will start to drift in that it becomes less effective. Latency increases. You'll see some degradation in application performance. And I'll also make the point that if you've been to any Rajant RCMP training, even our CNA training, you'll remember that the most, for what we hold, the most important metric of the network's effectiveness is the user experience of the application. So, at the end of the day, you might be looking at BC Commander and like, this might not look so good, but the application is still running great. So we're gonna take a look at that real quick and show you show you how that could start to affect and relate to network drift. But what is network drift? Network drift. This can be your network is going to be impacted by mobile infrastructure movement and placement in non-optimal locations. You're going to find that over time, with the number of hands in the pie or fingers in the pie, you might have some misconfigured radios that have slipped into the network. Also, we know that this never happens, but wired network, conditions change. So, somebody adds a VLAN, reconfigures a trunk. We've seen switch ports go bad. The RJ45s connected to the Ethernet ports, they go bad. Things like that happen over time. So all of these things can certainly contribute to network drift. So as I was talking about earlier, you'll see this graph here. We're going to talk about that here in a minute, but protocols that can help maintain your application performance, APT, automatic protocol tunneling. Automatic protocol tunneling allows breadcrumbs to mesh over Ethernet and fiber. Well, copper and fiber, but high-speed, wired links. We have embedded in APT a proprietary loop prevention protocol. This prevents breadcrumbs from creating an ARP storm, potentially. It works within the confines of spanning tree protocol, but you don't need it. As long as breadcrumbs can see each other over their Ethernet port, they have their own proprietary loop prevention, so you don't necessarily need to have spanning tree. But it's a standard for a lot of networks, so we understand that a lot of IT managers want to keep it on. And then also Instamesh. That's the magic sauce. That's what we bring to the party. So Instamesh is the routing protocol that has breadcrumbs making routing decisions on a packet by packet basis. So all of these things work to keep your network and your applications running as optimally as possible. And I say as possible because, as we talked about previously on the previous slide, there are many factors that can come into play that could potentially start to disrupt that. So as you can see in this graph here, we have our application performance that's running at a fairly consistent rate up until the time when it doesn't. So, and as you can see, the green line here, that's the indicator of network drift. That's the effectiveness of the network itself. That's you looking at BC Commander and like, ooh, my latency is getting a little high, and I've got a couple of breadcrumbs that are not that have poor costing or poor SNRs where they used to have great SNRs and great costing. So it's you start to see some of that stuff. Now, I kind of liken it to the death of 1,000 cuts. What happens is over time, you have trailers that go down because of solar panels that are not getting charged anymore. You have misconfigured radios in haul trucks that are no longer, really reporting well to the fleet management system. You have you have physical issues like busted antennas, ingress RF cable, things like that. There's several things that could cause network performance to start to degrade over time. So and as Phil's going to point out in his presentation, especially in mining, you have geographical changes. Like the mine moves, it gets deeper, it gets wider. They move to a different ore body, and they don't change any of the infrastructure. So all of that stuff will impact the performance of your network over time. So let's talk about BC Commander. So BC Commander is probably the most powerful tool in your toolbox. Rage's BC Commander is a proactive network management platform that helps recognize network problems early by monitoring performance and assisting with conducting the most root cause analysis, and that is by monitoring mesh links. And we monitor mesh links on a packet by packet basis. These are real-time diagnostics. Looking at your cost, at your mesh link cost versus your signal to noise ratio gives you a quick indication of how those mesh links are performing. By identifying these issues before they escalate, you can start to really thwart the efforts of network drift in trying to destroy your network and destroy your application performance. So some examples of what we're talking about. So this first warehousing example here was a problem that we were kind of sent in to fix. This was kind of a proof of concept. What they were doing was they were using robots with simple Wi-Fi connectivity. So they were doing Wi-Fi clients and they were doing simple hotspot, Wi-Fi hotspots. And the problem is they were losing Wi-Fi connectivity on the robots, and the robots were stopping and they were dropping data. So this became a Rajant demo / proof of concept. They were not allowed to mount any hardware on any of the bots. So they still wanted to use their Wi-Fi client connectivity. So what we did was we had a Rajant sales engineer come onto site. He literally brought 3 Cardinals in his demo kit and set them up. Set them up to mesh and for access point. He enabled some access points so the robots could connect to it wirelessly. Using the 3 Cardinals, he covered the entire warehouse space, and the robots had 0 issues of connectivity for the entire day. The robots just ran, and that proof of concept turned into a sale on the spot. He didn't get to bring his nodes home; they bought them. So it was a great example of walking in and solving a problem very simply with a very, very simple solution, just turning them on and letting them work. The other warehousing example I want to talk about is a little more telling in that, first of all, as you can see, this is putting an RF network inside a Faraday cage for the most part. Very dense, a lot of metal, a lot of reflectivity. This is kind of an RF nightmare, right? So the warehouse customer was experiencing outages. Now these are pallet robots that move throughout this 7-story structure here, or 7-level structure, I should say. And you try to imagine that whole rack system there that's filled with pallets, because that's what these robots do. They slip underneath the pallet, they pick it up, and they move it to where it needs to go. What they were experiencing was dead zones. Now, in the Rajant deployment guidelines, we specifically talk about something we call the rule of 2s. And that is every infrastructure piece needs to be communicating with 2 other infrastructure nodes on 2 radio interfaces. And those radio interfaces need to show an excellent SNR and an excellent cost. That is a cost of 5,000 or less. So in that, when our engineer went on site, our sales engineer went on site, he started looking around and he looked at the infrastructure, and they were missing some backhaul stuff, and they certainly did not have the infrastructure deployed within the Rajant guidelines. All he did was go in there and move 3 or 4 nodes so that everybody had connectivity to 2 or more, and the robots started running absolutely seamlessly. The problem with these robots stopping is the fact that somebody has to climb into that structure, go get the robot, move it to a safe location, get it restarted. and then get out of there before everything starts up again. So they have to completely stop operation. So that's the biggest, and these are keep alives, these are heartbeats. As soon as those robots lose communications, they just stop where they are. So you can understand how, like, losing communications in a situation like that's a very critical situation. So the solution here was follow the guidelines, and Phil will talk about that too in his presentation as we move forward. But this was literally just he showed up, and in less than a day, this problem was fixed, and they didn't need to buy anything. They didn't need to do anything but move a couple of units, and I think they did do some optimization work on the configuration, because as some of you may know, the more nodes you add, you can make some configuration changes to kind of optimize based on the number of nodes in the network. And so that's some of the work that he did. But in less than a day, they were back to a brand new network, and the application was running flawlessly. Our next example is an oil and gas plant. So in this oil and gas plant, the partner had asked for some support. They were experiencing some issues with PLC connectivity. When the sales engineer got on the ground, he discovered that they were missing several key pieces of backhaul infrastructure, and that was something in the design of the network that they had said that they were going to place backhaul in certain areas, and so what had happened was they didn't follow through with getting that backhaul to where it needed to be. So what was happening is they had some areas that were very isolated, and they did not have the node density because they were going to put in backhaul. So they didn't have the density that was required to hop everything back out. So basically, the sales engineer showed up, said, "Oh, you guys needed Ethernet connections here." They put those in, and everything started working. They didn't have to buy any more nodes. They didn't have to do anything. They did some optimization work on the configuration. I think they moved a node or two, added the proper backhaul, and boom, the network was up and running with no issues at all. They did have one misaligned point-to-point that the sales engineer did help them align. It was a non-Rajant piece of gear, but he helped them align it anyway. And this whole issue was resolved in about 3 hours after the engineer got on site. My last example here is a Homeland Security situation where we had a presidential rally in Texas, and the partner, we've been on the phone with the partner for probably 2 days trying to do remote support. They had about 80 video cameras that they had absolutely no connectivity to. We could see from the edge, we could see some of the breadcrumbs just fine. There are others that weren't reporting. The physical inspections were, the physical installation and inspections looked great. However, they kept having like host flapping and things like that happening. As some of you may know, when you see that message, it's usually a networking problem. So that was something he kind of dove into. Got on the ground, found out that they had almost no backhaul connections, and the switches that they had installed were not capable, or were not enabled to do IPv6 multicast and UDP. So that's all, if any of you have been to training, you know that APT requires IPv6. So the engineer got on the ground, did some physical inspections, started looking at radios, started troubleshooting, solving the puzzle, and discovered that he had no APT connectivity, got into the switches, enabled multicast. They got some point-to-points going. They got some backhaul going, and in 5 hours, their 80 cameras were up and running. So again, they bought nothing except support, but they bought no new equipment. They didn't have to upgrade equipment. They didn't have to upgrade firmware. Nothing crazy. It was just a matter of looking at your network, looking how it's performing, and solving the issue, like solving the puzzle. So I think that's the last example I have. So I think we'll open it up to questions.
Well, thanks, Stephen. We do have a question from my good friend, Rain Sade.
Rain, how are you doing, buddy?
Hi guys, can you hear
Long
me?
time, sir.
Yeah, good and you guys.
So
Yeah,
what's your question, Rain?
I was just wondering. I mean, typically when you get Mac flapping, I mean, I've not been in the field for some time, but I know that was always an issue with Mac flapping because I mean, you need to determine where it is actually starting from. And typically on some of the Cisco switches, you can sort of see where the MAC addresses are duplicated and all of this. Have you sort of had a new way of looking at where, even maybe on the breadcrumbs, to see who's instigating, where's that link missing between the two devices that you still have the MAC flapping from the backbone perspective?
So that's a really good question. So
answer that, Steve.
Yeah, go for it, Phil.
So in the new release of firmware now, or the new later releases of firmware, if you go to the topology view, you're going to see a whole heap of different colored stars. Whenever there is MAC flapping or a loop, you will actually see around the breadcrumb that it's actually that is actually in the loop, or actually one of the symptoms is actually reporting on that breadcrumb. You will actually see an APT in loop indication on the actual breadcrumb icon itself. So that's a very, very clear, easy way to identify MAC flapping breadcrumbs that are caused by spanning tree loop mismanagement. You also get MAC flapping when you have, say, a third-party access point connected to your wired network, and you have the same AP connected to a Rajant breadcrumb. The reason that we get that MAC flap then is because we have an Ethernet port reporting a MAC address, as well as a wireless InstaMesh packet on the mesh itself, and they report within DT, which is 10 seconds. So that there will generate a MAC flap. But if you have a Cisco switch at the end of an APT or backbone link, you'll actually see in the topology view, you will actually have an indication that says APT in loop. And it's going to have I think it's a little red semicircle around the bottom of the where the star is.
Right. Okay, so basically then you can go to that switch and sort of look at why you're having that issue, maybe a VLAN issue, or maybe because when MAC flapping happens, you sort of have a cascade down the whole network, and
yes,
it becomes very unstable. So basically you have to either disable that port, make sure you've got your configuration correct, and then try and enable it again, because that's typically the main cause of it.
So what you'll see also within the error on the breadcrumbs, you'll see a list of MAC addresses. So if you weed out, because you'll see some of those MAC addresses will belong to breadcrumbs as well. So you'll need to weed out the breadcrumb MAC addresses. And when you start to see the third party, you start noticing the third party addresses, that'll also give you a place to look. But yes, as Phil pointed out, if you disable the Ethernet port on the breadcrumb that's affected and it goes away, you know where to start looking.
Yeah. And that was typically a very manual exercise to find which one it was, So I'm glad that's actually something you brought up in the new version, because typically to find that one, it's if you've got 200 breadcrumbs in your network, and you've got a lot of APT masters and slaves that connects to the network, then it becomes really a struggle to fault find it.
And also, also understand that breadcrumbs in different native VLANs that are talking, that'll cause it too. So that's something else that you might want to take a look. Make sure that everybody's native VLAN is the same. That's talking in the same segment.
Mm.
Well, thanks, Ray. Ken, you had a question. I think Jimmy answered it in the comments, but why don't you go ahead and ask it, so in case people aren't watching the comments.
Yeah, I just wanted to know what version of BC Commander we should be on, and the firmware for some of those things that Philip was talking about to be able to see in BC Commander. I think we're on 27, 28, but but I haven't seen that. But then again, I'm not sure I was looking for it.
Yeah,
Right.
look, I'm pretty sure it's version 11.28, and the way that you can tell is before, when we used to have an APT master and there was only one gold star. Now, if you go to the topology view and you have a look, if you have the right version, you'll see there'll be a gold star, a blue star, a purple star, and there'll be stars all over the place. And that'll tell you that you've got the right version.
Thank you. I appreciate it.
Okay.
Right. I don't believe we have any more questions. So, Phil, why don't you jump into your section?
Absolutely. Thanks, Todd. G'day, everyone. I'll say g'day because it's 1:30 in the morning over here in Brisbane. So please bear with me if I sound a little bit tired, but let's crack on with this. So I'm based over in Australia. Most of my partners are heavily engaged in surface mining. And we've learnt over the last 5-6 years that there is a critical requirement to actually track network drift. So how do we define network drift? So obviously there's going to be a degradation in system performance, but we can directly attribute it to physical changes in topology because our mine sites, our topology is changing daily on a or changing on a daily basis, 24/7, 365 days a year. That mine is always advancing. So one of the things that I've been focusing on with my customers in Australia is to have an agile and proactive support mentality to prevent network drift actually catching you unawares. Sometimes with network drift, it can be very, very slow in system degradation. Then, as Steve says, the whole thing just collapses in a heap, and then there's people running around trying to work out what's actually going on. Okay. We look at applications like BC Commander and BC Enterprise, right? And one of the things that we want to do is we want to pay particular attention to changes in system performance. And in order to do that, we should actually sit there and validate what performance needs we need and how we're going to actually plan and implement those performance needs. One of the things I encourage a lot of guys to do is to make sure that the antennas that they select are optimized for the scenario where they're actually going to be mining. So antenna gain, and I'll explain a little bit more in the next slide, is a direct compromise between range and elevation beam width. So the higher the antenna gain, obviously the range increases, but the elevation beam width will actually decrease. So looking at antennas, I've actually got our two standard antennas, our 5 and 6 dBi antennas over there in the top right-hand corner. You can see the E-plane beam width of the 2.4 is 30 degrees. So that's going to give you approximately plus or minus 15 degrees of elevation coverage from the horizontal. Come down to 5.8, we've got 26 degrees, so plus or minus 13 degrees. Before I carry on, I want to reiterate the importance of GPS on your breadcrumb. So it doesn't have to be a USB GPS. It can be a TCP IP GPS, but the value out of that little bit of information over there and the topology view in BC Commander is absolutely invaluable to you. So once you actually attach GPS onto your breadcrumb on your mobile platform, you get to see certain criteria in the peers tab, such as the Fresnel zone, the range between the breadcrumbs, and also your elevation angles between your actual nodes. And that can really, really identify for you where problems are actually occurring. So the demonstration I got here in this slide deck, you'll actually see the topology view. I've selected a truck, and the three highlighted nodes that you can see over there with the red circles around them, they happen to be some infrastructure. And using the GPS locations of all of those devices, we can actually look at the peers table, and you can actually see the angle of either elevation or depression of the truck with respect to those infrastructure nodes. At the moment, it's sitting, maximum of 4 degrees, 4.96 degrees. That tells us that we are in the prime part of the elevation beam width of the antennas, and there's a good chance that we're going to have very good SNRs being made on those particular channels. So keep in mind the angle and also the elevation beam widths. Let's go on to the next slide. So to put that into practice, we actually had this scenario triggered pretty much towards the end of last year and also start of this year. Had a mine, they were reporting poor application performance of their fleet management system. BC Commander itself didn't want to take snapshots. It was taking well over 15 minutes to take a snapshot, sometimes even longer. BC Commander couldn't actually communicate with all the devices, even though we could ping them. BC Commander's updates had this blue connecting state coming up regularly. And also, as the trucks were moving around the haul path, we could see, if you play with fleet management systems, we could actually see trucks ghosting all over the place. So they would track for a very, very short period of time on the mind map, and then all of a sudden they'd get stuck. And then 5 minutes later, they'd appear 3 or 4 kilometers away. The one symptom or the one complaint that actually triggered me in terms of network drift was that quote there. This thing has been getting worse for the last 3 to 6 months. So in our analysis and stuff, we look at the pit depth. Now they are 15-meter benches over there. I'm calculating, if you want to count all those benches up there, that's actually about 210 meters. And if you look under the E in recent mine assessment, the label of the actual slide deck there, you'll actually see a cross. That was where the original APT trailer was. So looking at that, you know, we've got a pit depth of 210 meters, almost vertical wall coming down into the actual pit to the mining area. So when we look at BC Commander, we look at excuse me, the trailer location. So that's the top little box I've got outlined over there. Being GPS located, it actually tells us that the altitude is 120 meters above sea level. And then the second box you can see in red down the bottom over there is actually a bulldozer. And that there is 93 meters below sea level. And we're looking at a total distance from the trailer to the dozer is around 470 meters. If you add 93 and 120, it's around about 210 meters, which goes back to counting all the benches before. And you can see straight away now that the angle of elevation is going to be a lot more than minus 13 degrees from the trailer and minus 15 degrees from the trailer to the dozer. So what was actually occurring in this scenario over here was we were actually seeing that the machines required multiple hops to actually egress the pit. So when we were doing things like Instamesh traces and so on and so forth, and trying to do throughput checks, the throughput checks would actually fail to start. The Instamesh traces would actually go through about 4 or 5 hops, then come up with a unable to complete trace. Steve spoke about the rule of twos, right? So the rule of twos states that each breadcrumb radio needs to be able to see at least 2 other radios with good SNR and cost. Once you implement that, if you have your APT infrastructure in the right location, you'll be seeing, you know, a maximum of 3 hops between your machine and the APT side. What this does is it actually optimizes your channel spectrum utilization, which means you actually free up more bandwidth. If you have multiple hops, 15 to 20 hops in the pit for one machine trying to get out, that is not efficient spectrum utilization. Okay. So what we actually did over here was we looked at moving the APT node itself, the trailer that was sitting up at the edge. It wasn't being effective at all. The good thing that we had with this trailer was it actually has an electrically steerable head end. So we can actually have a subscriber on there. We can actually point it to a base station of a point to multi-point or point-to-point link. By doing this and putting the APT node right at the working surface, the first thing that we did straight away, what we noticed was we reduced the hops dramatically. We went from 15 to 20 hops to about like 2. The throughput before, when we did the actual testing, when we did have successful tests, we were well under 2 megabits per sec average throughput in the pit. The second that we actually dropped that single APT node down there, which just happened to be a Peregrine, we could see reliable 50 megabits per sec average. In fact, the Cambium point-to-multipoint subscriber wasn't very well, or wasn't as aligned as well as it could be. And this actually got the guys to look at it and go, right, we're going to go back and actually see if we can get much more throughput, because it won't take long until 100 machines actually congregate in the area. Our latency dropped from, well over 100 milliseconds to below 25 milliseconds. Our application performance actually increased. Everyone was actually back in dispatch doing their job. And we actually encouraged the mine to actually start looking at how to run mesh mapper runs and all that sort of stuff. I just want to draw your attention once again to that topology view, so you can actually see the angle of depression from the edge of the pit all the way down to that bulldozer, and also to one of the other machines down there. And you'll see one of them is at 30 odd degrees, the other one's at 15 degrees, right? And that's just angle of depression. You can see straight away there that we are out of the main beam, main RF beam, and any connections that we are making are sitting right in the side lobe of the antenna. Side lobes are never, ever a good thing to actually rely on for communications. We want to make sure that that RF beam is covering as much as possible all the active machines in the actual pit. I'll go on to the next slide. All right. Different techniques that we have for that we've noticed that we need to improve on in our mining environments over here, especially in coal mines, which is where I am right now. Coal mines move dramatically. A lot of my customers, when they actually set up a coal mine, they'll build fixed towers. Some of them might be, concrete towers, and they're built there to last a long time. By the time that those towers with their backbones are actually built, the mine has progressed considerably. Coal mines are always chasing the high wall. The best position to put something that's permanent is not where the high wall is going to be in 2 or 3 years. So the fixed towers become pretty much, the coverage of a breadcrumb from a fixed tower becomes obsolete within 1 to 2 years, and we see guys trying to fire other point-to-multipoint links to actually get down into the pit. We've asked some of our customers to consider using skid-based towers, so semi-permanent type structures that can actually be moved on a financially viable basis, rather than trying to move a tower that can cost 3 months to move, and it's a $1 to $3 million evolution to do that. And then also with the APT based trailer infrastructure, so you'll see that trailer on the right hand side, that is one of those with the electronically steerable subscriber module. That allows, I've seen one of these trailers actually deployed from arriving at the bottom of the pit to legs out, mast up, and actually aligned in about 18 minutes. One thing I do want to discourage a lot of people from doing is actually sitting up at the top of a mine. You might be 500 to 600 meters high with an infrastructure trailer, and the first thing you don't do is go and buy 10 sector antennas and then just try and point them down into the pit. You have to remember that the elevation beam width is on the truck antenna itself. It cannot see up 45 degrees. Well, it can't see much further than 15 degrees. So that is one of the things that we're going around and finding that guys are actually trying to do right now, is they have these sector antennas and they're trying to focus the sector antennas all the way down to the pit. Yes, the RF coverage from that antenna is going to be better, but all you're going to do is increase the noise floor, and no one's actually going to be able to respond. The other thing as well, if you go to RCNP training, we'll actually tell you that you do not tilt linear vertically polarized antennas. And then all of a sudden we're doing it with a sector antenna. That negative impact is going to be felt on that actual antenna itself. So it's not the best way to actually do to solve this problem. The best way to solve the problem is, as we do with our mines that are 50, 60 kilometers long, we extend our backbone all the way to the edge. Right now, we're actually talking about extending the backbone into the pit. Okay. So how to monitor our networks. The most effective tools that you have at your disposal for monitoring Rajant breadcrumb networks is BC Enterprise, BC Commander, and Mesh Mapper. And I'm not even saying that from a sales perspective. I've seen third-party applications that attempt to provide the information and the data, and there's always going to be one to two things where they don't actually cover that aspect. You always go back to BC Commander and you'll actually find relevant information like an alert that actually tells you that there's a problem that some of the applications may miss. So if you're going to use things like PRTG doesn't actually get any of the alerts from BC Commander. You'll never ever see a faulted radio come up and say, WLAN 0 not, undetected or not working. So BC Enterprise is powerful. If you set up BC Enterprise properly with your reports, you can actually do trend analysis over a period of time. You can get reports on ping latency, channel utilization, noise thresholds exceeded, all that sort of stuff. When you're running Mesh Mapper, Mesh Mapper is for me is probably one of the most valuable tools that I've seen come out of Rajant, because it actually allows us to track the RF with respect to the infrastructure. There's a line item in there that says, remember, you need to filter all your working machines away, so that you only have the active vehicle that you're tracking and you're looking at its performance with respect to the infrastructure. So some of the mining vehicles that I actually favor for mesh mapping runs are going to be service trucks, because they go everywhere where there's going to be a dig unit, water carts, because in Australia we have a lot of dust, so those things go everywhere. And typically supervisor vehicles end up in places where normal people don't go to. Over on the right-hand side, we actually take the output of Mesh Mapper, which is essentially a GPS pickup. We can actually then present that in a three-dimensional GIS application like Global Mapper, QGIS, or whatever it is that you have. And you can actually get a really, really good visualization of how your comms is performing, and where it is actually degrading. And the good thing about looking at the trace path, which I've actually got highlighted over here, is you can see where your infrastructure is actually deficient in this pit. So once again, the best tools, Mesh Mapper is actually available on all nodes with GPS, and Mesh Mapper monitors essentially the InstaMesh application for you, because you have the cost, you have the SNR, you're getting a fairly good idea of how your machine is functioning with respect to your infrastructure. And also remember, like on some machines, like Caterpillar machines, the presence of a GPS puck, a little magnetic GPS puck, is not always feasible, especially on the great big 797s. You can actually get GPS information directly from the Caterpillar GPS, whether it's an MS352 or the latest one that they have. You can generate a GPS server on that and actually push out an NMEA string and get the breadcrumb to talk to that NMEA string over IP. And then you'll get if it's high precision RTK GPS on that autonomous truck, or semi-autonomous RTK GPS, then you'll get very, very accurate GPS information. So from the lessons learned, we can look at old and current snapshots. If you're into that sort of stuff, you can actually see your network drift throughout those snapshots. You got to realize that network drift is real, especially in surface mining. It is always going to occur. We move so much dirt on a daily basis. There must be some change in our RF topology that we need to know about. Third line over there, if you're looking after mines, nobody should know more about your network than you. And in the case I showed you before, the simplest fix is the most effective. We had people chasing, noise and different sources of RF interference and all that sort of stuff. And in the end, all we did was just move a trailer with a point-to-point link, and we solved the problem. Okay. You can't get away from the physical aspects of mining, especially in surface mining. All I need is a drag line or two to absolutely destroy an entire month of work. And I see it in most of the coal mines here. And once again, if there is scope creep, your network will need to actually address it, and you need to fix it. Okay. I noticed I had a few questions actually come in while I was talking over there, so open to questions right now. From Rain, I had, can one limit the number of hops, and how do you check your spectrum efficiency? You can't limit the number of hops, but you can actually make the number of hops more efficient. So by placing your APT or offload point as close to your as close as possible to your working face and obeying the rule of twos, you can actually optimize your hops to less than 3 hops. Spectrum efficiency, if you look at the receive percentage that's actually given to you in the details tab in BC Commander, that will give you an idea of how efficient your spectrum utilization is. Also, if you go into Mesh Analyze and you look at your frequency overlap and your frequency utilization, you'll actually see a number of bars that actually come up as a percentage. So that's that one there from Rain. And then I've got another one. Is there a resource where we can learn how to convert Mesh Mapper to 3D? That's the second question I've had after this webinar. I'm actually putting a bit of a guide together, and it's very, very simple. But what I'll do is I'll give it to all the sales directors in each of the regions once I've completed that guide. Sometimes I get way too focused in my assessments and stuff, and I can make it appear very, very simple for me, and it actually turns into something totally different for everyone else. So once I get one of the sales directors to actually go through and convert one, then I'll know that it's easy for everyone else to do. Okay. Any more questions? None?
Oh, last call for question. Oh, Oscar.
Oh, here we go. Oscar, could we force the route of hops we want to use instead of Instamesh define, or spend specific VLANs in a specific route? Not advisable. Instamesh is a routing protocol. The intelligence on Instamesh itself is determining the best way to actually route data. If you want to force the your hop route, you can by utilizing clusters, but you put yourself at a great risk. All you have to do is lose that one forced route, and you have no comeback from that. Okay.
I will tell you that in my almost 19 years of doing this, every time somebody has tried to outsmart Instamesh, they've broken the network. So I would suggest just let Instamesh do what Instamesh does.
Instamesh is really the only wireless protocol that can self-optimize the routing. Anytime you try to manually force a specific route, you're essentially doing away with redundancy and self-optimization. So, not advisable. With that, we'll wrap things up. I would like to thank everyone for spending the last 50 minutes with us. And I'd like to give special thanks to both Stephen and Philip for taking the time to put this excellent presentation together. I would also like to recognize Gizzy O'Toole from our marketing department. We couldn't put these webinars on without his production support. We appreciate everyone's questions. Getting perspectives from our channel partners and customers around the globe makes these sessions far more interesting for everyone. We hope you found today's session informative, and please watch for an invitation to our future webinar sessions. Have a great day.